Hello friends, have you ever wondered if there's another Earth out there hiding among the stars? Get ready to be intrigued as we uncover the secrets of exoplanets. These distant worlds hold mysteries beyond our wildest imagination. Join me on a journey of discovery as we venture into the unknown, exploring alien landscapes and encountering sights that will leave you breathless. Get ready to embark on an adventure that will ignite your curiosity and expand your understanding of the universe. But before we delve into the mysteries of exoplanets, there are three important questions which need to be answered. They are: do aliens exist in these exoplanets? Can we potentially shift to an exoplanet? How on earth do scientists even discover them? Let's answer these questions and uncover the secrets of these mysterious heavenly bodies. Let's first understand what even are exoplanets. Exoplanets, short for extrasolar planets, are planets that orbit stars outside of our solar system. They can vary greatly in size, composition and orbit, and they are of immense interest to astronomers because they offer insights into the diversity of planetary systems beyond our own. Exoplanets can be gas giants like Jupiter or rocky planets like Earth, and they may orbit their host stars at varying distances, from extremely close to very far away. Our universe is estimated to have over 100 billion galaxies, each with hundreds of billions of stars. If more stars have one or more planets around them, there may be billions or even trillions of planets in the universe. Till date, scientists have found over 5,000 exoplanets, out of which 59 exoplanets are potentially habitable. Now I'm sure there's a question in all of your minds. Why do scientists even discover and study these exoplanets? Why is it so important to us humans? There are three main importance of exoplanets. First, understanding planetary formation and evolution. Exoplanets help scientists learn how planets form and change over time. By looking at different exoplanets and how they move and what they're made of, scientists can improve their ideas about how planets like ours come to be. This helps us understand not just our own solar system, but also how planets form in other parts of the universe. Second, search for extraterrestrial life. One big reason why scientists study exoplanets is to see if there might be aliens out there. They focus on planets in the habitable zone, where it's just the right temperature for water to exist. If we find one, it could be a hint that there's life. Unfortunately, we haven't found any aliens yet in any of the discovered exoplanets, but studying these planets help us learn more about how many different types of life might be out there. Third, advancing astrophysics and technology. Studying exoplanets helps scientists get better at space stuff. They use fancy telescopes and tools to find and learn about these planets, which helps them make new discoveries and improve their equipment. By studying exoplanets, scientists also get to test their ideas about how planets work and how they interact with stars. This kind of research does not only teach us about exoplanets, but also helps scientists make progress in other areas of science and technology. As I mentioned earlier, scientists have discovered around 5,000 exoplanets, and among them is the farthest exoplanet from Earth, known as Sweeps 11. Sweeps 11 is an extrasolar planet orbiting the star Sweeps J175902.67-291153.5, I know a really weird name for a star, in the constellation Sagittarius, approximately 27,710 light years away from the solar system, making it the most distant exoplanet known. This planet was found in 2006 by the Sagittarius Window Eclipsing Extrasolar Planet Search (SWEEPS) program that uses the transit method. Transit method is one of the most widely used methods of discovering exoplanets, which we will discuss in detail later in the video. Scientists have also discovered an exoplanet which is relatively closer to Earth compared to other exoplanets. The closest known exoplanet to Earth is Proxima Centauri b, which orbits the red dwarf star Proxima Centauri in the Alpha Centauri star system. Proxima Centauri is the closest star to the Sun, located about 4.24 light years away from Earth, which is approximately 25.2 trillion miles from Earth. Its mass is 1.27 times of Earth's, and it takes 11.2 days to complete one orbit of its star. Its discovery was announced in 2016. Now, how do scientists discover exoplanets? There are multiple methods used by space organizations for the discovery of exoplanets, but the most widely used methods are: first, transit method. The transit method is one of the most widely used techniques for discovering exoplanets. It involves observing the slight decrease in the brightness of a star as an exoplanet passes in front of it, blocking a fraction of the star's light, which creates a dimming of light. This dimming helps astronomers figure out things like how big the planet is and how it moves around its star. An example of an exoplanet discovered using transit method is the Kepler 186f. Kepler 186f was discovered by NASA's Kepler Space Telescope in 2014. It orbits a red dwarf star called Kepler 186, which is located about 582 light years away from Earth in the constellation Cygnus. The second method is the radial velocity method. The radial velocity method, also known as the Doppler method, is another commonly used technique for detecting exoplanets. This method depends on detecting small movements in a star's position caused by the gravity of a nearby planet. As a planet orbits, it pulls the star slightly toward and away from us, which changes the star's light in a predictable way. By analyzing these changes, scientists can figure out details about the planet, like how heavy it is and how it moves around its star. 51 Pegasi b, also known as Dimidia, is an example of an exoplanet discovered using the radial velocity method. 51 Pegasi b is a gas giant exoplanet that orbits the star 51 Pegasi, located about 50.45 light years away from Earth in the constellation Pegasus. Its mass is 0.46 times of Jupiter's. It takes 4.2 days to complete one orbit of its star. Its discovery was announced in 1995. The third method is direct imaging. Direct imaging involves capturing actual images of exoplanets by blocking out the light from their host stars using specialized instruments. This can be tricky because a star is much brighter than the planet, but it works well for spotting big, young planets that are far away from their stars. Direct imaging method was used in the discovery of HR 8799e. HR 8799e is a gas giant exoplanet with a mass estimated to be 10 times that of Jupiter. It orbits its host star at a distance of about 14.5 astronomical units, which is roughly the distance of Uranus from the Sun in our solar system. Its orbital period is approximately 50 years. Coming back to Proxima b, let's discuss as to what are the potentially available resources which might be useful in sustaining life on this exoplanet. The first is energy. Proxima b receives energy from its host star Proxima Centauri. However, Proxima Centauri is a red dwarf star which is much cooler than and dimmer than the Sun. As a result, Proxima b likely receives less energy compared to Earth, and any potential energy resources such as solar power would be limited. The second resource is water. The presence of liquid water is a crucial resource for the potential habitability of a planet. Proxima b is located within the habitable zone of Proxima Centauri, where conditions might allow for the existence of liquid water on its surface. However, whether Proxima b has water or other volatiles remains uncertain and requires further observation. The third is minerals and elements. Like Earth, Proxima b likely contains a variety of minerals and elements in its crust, mantle, and potentially its core. These resources could include metals, silicates, and other materials. However, without direct observation or exploration, it's challenging to determine the specific composition and abundance of these resources. The fourth is atmospheric gases. Studying the composition of Proxima b's atmosphere could provide valuable information about its potential resources. Atmospheric gases such as oxygen, carbon dioxide, and methane could indicate the presence of geological or biological processes. However, current technology is not yet capable of directly analyzing the atmospheres of exoplanets like Proxima b. Although Proxima b is the closest exoplanet to us, this planet is not inhabitable. There are 5 primary reasons for this. First is proximity to its host star. Proxima b orbits very close to its host star Proxima Centauri, completing one orbit in just over 11 Earth days. This proximity means that Proxima b is likely tidally locked, with one side always facing the star and the other in perpetual darkness. Extreme temperature differences between the two sides could make it challenging for life as we know it to exist. The second reason is potential lack of atmosphere. There are uncertainties about whether Proxima b has a substantial atmosphere. An atmosphere is crucial for regulating surface temperatures, distributing heat, and protecting against harmful radiation. Without a stable atmosphere, the surface conditions on Proxima b could be harsh and inhospitable to life. According to the study published in the Astrophysical Journal Letters, that all oxygen would escape from Proxima b's atmosphere in 10 million years. The third reason is stellar activity. Proxima Centauri is a small, reddish star that often has powerful outbursts called superflares, happening about every 2 hours. These outbursts produce intense ultraviolet radiation. This can be extremely harmful to humans and other living organisms alike, in case we ever shift to another planet. Fourth reason is atmospheric loss. The proximity of Proxima b to its host star and the associated stellar activity could lead to atmospheric loss. High energy particles from the star could strip away molecules from the exoplanet's atmosphere over time, particularly lighter elements like hydrogen and helium. The most important reason is unknown surface conditions. Our current knowledge of Proxima b's surface conditions is limited. We do not know if it has liquid water, a solid surface, or other essential features for life. Without direct observations or detailed modeling, it's challenging to assess the habitability of Proxima b's surface. In addition to Proxima b, scientists have discovered numerous other exoplanets. WASP 121b is an exoplanet located about 880 light years away from Earth in the constellation Puvis. It was discovered in 2015 and is classified as a hot Jupiter. After all, what is a hot Jupiter? Hot Jupiters are gas giant exoplanets similar in composition to Jupiter, but with incredibly short orbital periods. Their close proximity to their stars and scorching surface temperatures earned them the nickname Hot Jupiters. Now, what makes WASP 121b particularly intriguing is its extreme temperature, with some regions of its atmosphere reaching temperatures exceeding 2500 degrees Celsius, which is approximately 4532 degrees Fahrenheit. HD 209458b, also known as Osiris, is one of the most studied exoplanets. It was discovered in 1999 and is located about 150 light years away from Earth in the constellation Pegasus. HD 209458b is a hot Jupiter with a highly inflated atmosphere, and it became one of the first exoplanets to have its atmosphere directly detected. Gliese 581z is an exoplanet located about 20 light years away from Earth in the constellation Libra. It was discovered in 2010 and gained attention for its potential habitability, as it was initially thought to orbit within the habitable zone of its host star Gliese 581. However, its existence has been debated and further observations are needed to confirm its presence. Kelt 9b is an exoplanet located about 670 light years away from Earth in the constellation Cygnus. Discovered in 2017, Kelt 9b orbits a hot, massive star and is one of the hottest exoplanets known, with surface temperatures reaching over 4000 degrees Celsius. Its extreme environment makes it an important target for studying the atmospheres of hot Jupiter exoplanets. An important question which might be lingering in your mind is, can we potentially shift to an exoplanet? If we talk about the near future, the answer is no. There are numerous challenges and barriers that make interstellar travel and colonization of exoplanets extremely difficult. The first is vast distances. The distances to even the nearest exoplanets are immense, often measured in light years. Traveling such distances with current propulsion technology would take thousands or even tens of thousands of years, making it impractical for human exploration or colonization. Second is technological limitations. Current spacecraft propulsion systems are not capable of achieving speeds anywhere near the velocity required for interstellar travel within a reasonable time frame. Developing the technology for faster spacecraft capable of reaching nearby exoplanets would require significant advancements in propulsion systems and material science. Let's take the example of Proxima b. Proxima b is at a distance of 4.24 light years from Earth. So it will take us 4.24 years to travel to Proxima b if we travel at the speed of light, which is 299,792,458 meters per second. The third reason is environmental and life support challenges. Even if humans were able to travel into an exoplanet, sustaining life in a foreign environment presents numerous challenges. Exoplanets may have vastly different atmospheric conditions, surface conditions, and levels of radiation compared to Earth, making it difficult to establish habitable environments. The fourth is resource limitations. Establishing colonies in exoplanets would require access to resources such as water, food, energy, and building materials. Transporting these resources over interstellar distances would be prohibitively expensive and technically challenging. The fifth reason is unknown conditions. Our knowledge of exoplanets is still limited, and many aspects of their environments and potential habitability remain unknown. There may be unforeseen challenges and hazards associated with living on exoplanets that we have not yet discovered. Hence, traveling to other exoplanets would not take place anytime soon, given the enormous distances between the stars and the time it would take to travel between them with our current technology. Perhaps one day a robot will visit an exoplanet like the rovers on Mars, but that day too is still very far in the future. First, we have to learn how to travel much faster and further in space than we've ever gone before. Keeping humans alive to complete such a long journey is probably the biggest challenge. Today, NASA is concentrating on the steps to get humans to Mars, which is our next door neighbor.